Hello, my name is Jeff Buffum, and we're going to be talking a little bit about identity-based management. One of the aspects of 5G that gets left out is the fact that the identity of an individual, or a subscriber, as I'd like to call it, is entirely different in fixed line than it is in mobile. And then we need to look at that in the context of the 5G world that people are looking at the convergence going to. And then I'll talk a little about mobile subscriber management and wireline subscriber management, and then we'll talk a little about a concept derived from the Broadband Forum's work called a network-enhanced gateway. So let's talk a little bit about what a subscriber is. When we're talking about mobile, we're talking about a UE, a user device, okay? This is actually who you are. Your cell phone is who you are. But if you're talking about wireline subscriber management, you're talking about where you are. You're talking about a place. We tend to put RGs in there and have tons of devices hidden behind those RGs, but we don't know anything about those devices. We just know that there's bandwidth and traffic coming out of those locations. On top of that, authentication is done differently. We authenticate all our mobile devices by their SIM. But all of our laptops, Wi-Fi devices, these devices don't have SIM. They're identified by usually a simple thing as it's a DHCP request or a PPPoE authentication. So there's an entirely different perspective here on how subscribers are managed between 5G and wireline. And this is something that the wireline vendors have been wrestling with. 5G guys aren't wrestling with it because they think they're right. They want to manage the devices. Well, in a way, if you think about it, managing the devices is the right way to go. You want to manage the individual devices. You don't want to be managing places. You want to be managing people. Who, not where. So in a 5G converged world, this is the magic picture we've all seen a million times before of 5G convergence, right? But the difficulty with it is, it works wonderfully if you're a vendor that has fixed line and mobile, because now you're converging your networks. You're lowering your operational expenses, you're making your world better. But what do you do if you don't have a mobile network? Convergence isn't the way to go. But by the same token, you don't want to remain in this fixed line environment of giving everyone services where they are. So people can partner, they can do all kinds of various options, but how do we bring this who to the wireline? So let's take a little look here at the way mobility today does subscriber management. This is a standard handshake chart for a 4G device authentication. Essentially what you're talking about here is, this is also the way that, for example, voice over Wi-Fi, it gets gatewayed in through an EPDG and the device gets authenticated. As we talk about 5G convergence, they're talking about putting gateways in your home that will talk to the mobile. So therefore, what they're doing is moving the mobile services into your home. But in every case, each device is individually authenticated. What about fixed line? It should be 5G. 5G essentially is identical handshakes. If you look at it just as a pictorial sense, it's the same handshake. Messages change, they have better authentication controls, they've eliminated certain weaknesses in the 4G handshake, but essentially, again, it's the device authenticating to the network, not where you are, but who you are. So let's look at fixed line and remind ourselves of how it works. It's all about where you are. You set it up, you have an RG in your home, your devices connect to that RG. The RG itself uses DHCP to get an IP address. You have to authenticate the device, you have to make sure it's all there. You set the service up to that location. So the service is tied to the location. So if I have more and more people in my home sharing my service, there's no way for the service to know that more devices are coming online. All they see is more and more bandwidth capacity being used. All the devices in your home get private addresses, of course. So this is the model that the fixed line had been using for quite some time. PPP OE is still used, but it's mostly DHCP option 82 based. So what's the next step? Where's the way to move a fixed line from being about where you are to being about who you are? Because if you think about it, from a customer's perspective, whether you're wireline or wireless, they want to be treated the same. Wouldn't you like to be able to take your device and go into your next door neighbor's house and get your service there without interrupting your neighbor? Wouldn't you like to be able to go to your local coffee shop that might happen to be serviced by your service provider and get your service at the coffee shop and not have to fight for the bandwidth that's there? These are the kind of things that become possible when you're looking at who you are, not where you are. So what we did was we took a look at, we partnered with another vendor, I shouldn't say that, another service provider, and we are working on essentially taking the work that the Broadband Forum did on TR 317, which many people have heard about, and TR 328, where they wanted to virtualize the home into the cloud, or virtualize the business into the cloud. We looked at this, and we looked at the aspect of subscriber management, and we came up with this concept, which we've labeled Network Enhanced Gateway. Now, the Network Enhanced Gateway is all about moving subscriber management off the BNG and into the cloud. The idea being is when you connect to the network, you come in and you get authenticated in the cloud. Your device is authenticated based on a combination of attributes, a device fingerprint, which can be worked out based on a whole plethora of attributes. For example, devices have a certain habit of behaving certain ways. They pass certain attributes with DHCP. They pass them in a certain order. These things all generate a unique signature or fingerprint for that device. This allows a device to move to a new location and not have to log in again. When that device shows up, it can be identified, and you know that device, and you're able to give it services. Obviously, as eSIM comes along and more devices use eSIM, that would be a better way to authenticate a device in a more secure aspect. But for now, this allows you to authenticate devices that don't use a SIM or an eSIM. Obviously, gatewaying of the SIM and eSIM, or I shouldn't say gateway, authenticating by that is also supported. There's a single device database. That means that your subscriber management system can be distributed. You can have servers in the appropriate locations. You don't have to have massive scaling. You don't have to force the traffic to a single location. Latency through these devices has been verified to be sub 1 millisecond. So it's not going to add significantly to the latency, but it does allow you to now centralize your subscriber management back to the data center, or your edge compute center even more likely. It gives you per device statistics, because since you recognize a device, you can collect statistics on that device. Data is always a good thing. Data is God. Data is money. And that's where this also gives you advantages. You can also have multiple service profiles for a single device. So if the device is doing multiple different services, you could actually give them different treatments for different services. This can all be handled. It also allows, as I've shown with that kind of silly colored Venn diagram, flexible device groupings. A good example of this would be, let's say you're at your home or you're away on business, but you're also the IT person for your family. So you would then have privilege to get to your family's equipment from wherever you are to fix problems. These are the kind of capabilities that become possible when you have centralized subscriber management that are much more difficult to do when you have people being isolated by where they are, because now you have it's a much more flexible system. And finally, of course, everyone has a NAT running in their house, which means you're giving a public address to every single endpoint in your network, because everybody has to have their own public address. When you have centralized subscriber management, you can put everybody on a private address and then bring that traffic in and run it through CGNAT. So you don't have to have every customer with their own private address, their own private residential gateway. However, the system can understand whether a customer needs a public address because they want an RG in their home, or whether they don't need a public address, in which case you can just service them with layer 2 alone. That actually simplifies the access devices at the endpoints because they can all eventually become layer 2. And that allows everything to be treated the same. When a customer comes in, whether through a community Wi-Fi, through a personal Wi-Fi, through their neighbor's Wi-Fi, hopefully with their permission, they are able to get the same service. And this is the intent of the network enhanced gateway concept. One of the things people always ask about is security. If I'm in my home and I bring my traffic in at layer 2, how do I ensure that my traffic is protected? Well, traffic from any endpoint can be brought into this network enhanced gateway through something as simple as a GRE tunnel or an L2TP tunnel, or with a standard access network running with TR-101 today. They all come in on double-tagged VLANs. That double-tagged VLAN is essentially a tunnel. It isolates your traffic and keeps it separated. All of these various flexibilities allow you to provide a very secure, greatly simplified access network with all the flexibilities I've just defined, where it's all about who you are, not where you are. So touch on some of the last few aspects of it. You can do residential services this way, you can do business services this way, because remember, everything from an endpoint back to the subscriber management system is kept isolated, so no businesses have to worry about traffic bleeding over or crisscrossing. It allows for a complete, as I said, layer 2 in the premises, and it also reduces on a scaling basis. Now you think about it today, you've got all these MAC addresses coming in from all these locations, and people have MAC address scaling and all these other access network problems. If you start putting these people in, for example, a GRE tunnel, you've just taken your MAC address space down by an order of magnitude, because now each home is one MAC address, not a whole plethora of MAC addresses. And that's still operating at layer 2, by the way. You don't have to have an RG to make that happen. Also, it still supports NAT in the CPE, which is very important. You don't want to disrupt your current customer base, but it allows you to migrate your customers to a much lower cost and simpler access method. And that's pretty much it. So I'm a little ahead of schedule. Give me back a little time.
Great.